Now, let me summarize the entire details of the today's session. So, we started with the introductory part where we was planned to discuss about the simply supported beams. For that, we were planned to draw influence line diagram for shear force, support reactions and bending moments. Problems with one point load, multiple point load and UDL were our objectives of the day. So, accordingly with the objectives, we started with the definition and what is an influence line diagram. Then we proceeded with a simply supported beam with unit load. For that we evaluated the reactions considering the equilibrium equation sigma V0, sigma Ma0. We found out what is VB, then VA, then we draw the ILD for VA and VB. Once we obtained the ILD for VA and VB, then we proceeded with the shear force and bending moments. Shear force and bending moment should be evaluated at any particular point on the beam in between A and B. So when that is the point, so for that point is taken as C, which is at a distance of Z. So this is the positive sign convention for the shear force. When unit load is before C and after C were the two conditions. Before C, we evaluated what is the shear force, and the second point is after C, what is the shear force, and we got two equations. Accordingly, for the two equations we plotted, that is x 0 to z, x z to l were the two different conditions substituted, and we got the shear force diagram. And the shear force, when it is for the point load, it is z by l and 1 minus z by l. Next we proceeded for the bending moment. So for the bending moment, again the same point C was considered. So the two cases were load is before C and load is after C. So we can consider any of the spans. When the load is there, any of the spans can be considered, and when the load is before C, the condition was x varies from 0 to z. For that we arrived at the equation. Similarly, when the load is after C, the condition was x varies from z to l. So we arrived at the equation. After substituting and doing the calculation, we ended up with this plot where the point maximum bending moment is found to be z by l into l minus z. With these numericals, we finally summarized all the details, plotted all the graph in a single stretch. Simply supported beam, ILD for support reaction, VA, VB, shear force and bending moments. With this background, we started with some numericals where there is one point load of 20 kilonewton and the beam is of span 10 meter and the point C is at 5 meter. So VA and VB were evaluated considering the ordinate. So only one load means at the peak point you are going to keep and you are going to evaluate the reactions. Now for the shear force, maximum negative and positive shear force were calculated, then similarly bending moment. And the next case was where there were 2 point loads. So when there were 2 point loads and the two loads are at a distance of 2 meter, then for each of the case, the one load is kept at the maximum point, preceding or succeeding the previous load. In order to evaluate VA, the load is preceding this, whereas for VB, it is succeeding like this. The load positions are like, make sure how we have placed it. So just recollect the previous part and then we just substituted with the corresponding ordinates in order to evaluate VA. VA means in the VA graph, whatever the ordinates you are getting, that you are substituting in VB. Whatever ordinates for VB, shear force in the negative zone, negative ordinates, positive zone, positive ordinates. So multiply the load with the corresponding ordinates, you will end up with the solution. And the last case was with the UDL. So whenever UDL, it is the area. Whenever it was a point load, we used to multiply with the ordinate, but whenever it is a UDL, it is a area factor. 2 into 0.8, half into base into height. So 2 ordinate area multiplied by the load intensity. Similarly, we calculated shear force negative, positive, bending moment. With this, I would like to summarize today's session. So these are the outcomes for the day. We have learned how to draw influence line diagram for a simply supported beam with a unit load moving on the beam when the unit load moving on the beam is considered, we will get the support reaction VA is equal to 1 minus x by L, VB is 1 x by L, and shear force negative is Z by L, shear force positive is 1 minus Z by L, and bending moment is Z by L into L minus Z. And we learned how to interpolate and obtain the ordinates for shear force, bending moment, and support reactions. Thereby we learned how to evaluate the shear force and bending moment calculation using ILD for the given set of moving loads or rolling loads. Then we learned how to draw influence line diagram for support reactions, shear force, and bending moments. These 5 terms are very important. They are really important. Shear force negative is Z by L, shear force positive is 1 minus Z by L, and bending moment diagram or bending moment ordinate is Z by L into L minus Z. If you know these things, you can plot it, and next thereafter by just interpolating, you can find out all the values for the given set of loads. It can be support reactions, shear force, negative, positive, bending moment, or anything. So we can calculate each and every parameter related to the simply supported beam. Thank you for your patience hearing. Thank you.